In this question, you can follow this figure, and this figure consists of this elevator, and in this elevator you can observe this is inclined plane. On this inclined plane we have a block of mass small m which is stationary with respect to this incline, and this elevator is moving with acceleration root 5 a naught, and you can observe in this figure the component of this acceleration a naught in the upward direction and 2a naught in the horizontal direction, leftward direction. Okay, the surface is rough. This surface is rough, and coefficient of the friction between the incline and block is given as mu s, and we need to calculate the magnitude of the force exerted by incline on the block, and we are given a naught is equal to g by 2, and this theta, that means inclination of this inclined plane with the horizontal is 37 degree, and mu s is equal to 0.2, and we are given these four options. We need to calculate the magnitude of the force exerted by incline on the block. You can observe this block is in contact with the inclined surface. That means the contact force between the block and inclined surface should be normal reaction, resultant of the normal reaction, and friction force. So here we need to calculate the resultant of the normal reaction and friction force. Let us assume this contact force is F vector, because we don't know the magnitude as well as direction. Okay. If we consider other forces acting on the block, this is only the weight that will act in the downward direction, small mg. Okay. Let us consider the directions. So let us x-axis is a rightward direction and y-axis in the upward direction. We can express these accelerations as well as weight in the vector form. We can write this a naught with the symbol j cap. Okay, and this 2a naught should be multiplied with the minus I cap, because this is moving in the negative x direction, and this weight is acting in the downward direction, so this is minus j cap. Correct. Now the forces acting on the block, contact force, that is F vector, and weight. So here we can write equation of motion for the block. Equation of motion of the block should be equal to F vector plus mg multiplied by minus j cap. That should be equal to acceleration multiplied by mass. M multiplied by acceleration is equal to minus 2a naught I cap, and this is also acceleration a naught vertical component, so we should write here a naught j cap. Okay, we can rearrange this equation because we are interested to calculate F vector. So this F vector should be equal to, after rearrangement, this will be equal to small m. Small m we can take common, so small m, and in bracket we will have 2a naught I cap, and here we can take this term in the right hand side, so this should be equal to plus a naught, right, and this is plus g, and this is j cap. Correct. Now we know a naught is equal to g by 2, so we can write here this is m multiplied by minus 2 multiplied by g by 2, right, I cap, and this is equal to a naught. A naught we know this is having the value, this is g by 2, so let us write this is g by 2, g by 2 plus g, and this is j cap. Correct. Now we can write this m is multiplied by this 2 and 2 will get cancelled, this is minus g I cap plus 3 by 2 g j cap. Okay, but we are interested to calculate the magnitude of this contact force, so let us take the mod of this. So mod of F should be equal to under root, this is g square m multiplied by this is minus g square plus 3 by 2g whole square. Correct? So after rearranging and solving, we'll get this value. This will be equal to 4 and this is 9. This is root 13 small mg divided by 2. So option should be correct. This one, D option should be correct. This is the correct option.